Morning, thanks for coming out for what could be a relatively early morning session, depending on whether you're a morning person or a night person. And like any technology session, it's good to see everyone from the back. So if you have a hard time hearing me, I'll try and stand in front of the mic. I've got, as I'm looking at this, I see there's 81 slides here. This is not going to be an 81 slide PowerPoint presentation. I'm going to get more of the PowerPoint myself at some point in time, and I'm going to just go into a live demo and talk about what does Hyperconvergence really look like. So how many people have heard the word Hyperconvergence in the past year or so? I mean, I think it's slowly going from a buzzword to something more significant, like an infrastructure paradigm or model, but there's still, I know the first time I heard the word, I kind of rolled my eyes a bit because I'm thinking, here's another buzzword, and I'm not even really sure what it means. It just has another hyper. So is it hyperbole? What does this really mean? So we'll get into talk about that. But just to introduce myself, my name is Mike Lyon. I work at Scale Computing, and I've been there just over 5 years. I work as our service delivery manager. So I built out our team that does implementations that are typically delivered remotely. So after the cluster has been installed, people need to move over existing workloads, whether they're physical or virtual. So our team helps with that, network configuration, other services that a real small organization may not have the resources, or they don't have a technology partner to get those things installed. And I also spend the other part of my time working on our, testing new products, which is a lot of fun, and then also get out to be on the road and meet with people, which is really what I enjoy the most. And talking about scale really quick, what do we do? Well, we are a hyperconverged infrastructure platform company. We aren't selling software or hardware, we sell a full appliance stack. So all of your resources, your servers, storage, and virtualization are combined into one platform product, which is really the idea of hyperconvergence. And we've been around for 7 years, and we've been in the hyperconverged market for 4. We were the first to market with a truly hyperconverged platform, specifically designed for the SMB. And almost everyone who's here is in our target market, really. Our target market is small to medium enterprises, but we wind up in a lot of healthcare, higher ed, middle ed, and local government, just because of the challenges and problems, budgetary concerns that are faced in those particular sectors really resonate with our users in the value proposition. And also it makes sense for hyperconvergence as well. So if you look at your typical virtualized solution and how it's been done, we have layers of components, and starting with some type of SAN or NAS, and that can be as elaborate and complicated and expensive as you want it to be, or it can be a Drobo or a MyCloud, something sitting off the shelf, depending on what they're comfortable with, their budget allowed for, the expertise would be. You've got a network layer beyond that, and you've got your physical hosts. So in this case for ESXi, now we've got another layer there, and we've carved out some ones, and that would say a nice busy array. Presented those to ESX. Now we're going to create some data stores. So they've got places to write their data. Now we can start creating VMs and provisioning those VMs disks. So in a way, virtualizing was a great idea, and it helped us to save resources, at least as far as not having physical server sprawl. The problem was that we really spent, as IT personnel, we changed how we were spending our time and spending our money. So rather than managing this huge herd of physical servers, we were managing a smaller herd of more powerful virtual servers, but then all the underlying components that we didn't have to manage in physical environments, we started to have to manage. The SANs, the SAN networks, often complicated and elaborate networks that go at the physical host level. For some people having to get a network in, understanding bonding, or repo channel, things like that, that's a level of expertise that they would have to pay for or bring in outside consultants. And the long story short is that this is a complicated model for smaller IT shops to be able to implement, manage, support. And let's look at the data path here. So inside of a VM, to actually write and read, I have to go through that entire stack just to get access to a physical disk and commit a write. There's 7 hops from the time you're writing inside of the VM down to disk. Forgetting about the complication of managing it, thinking about how complicated that I/O path is for your VM data. That has to be simplified somehow. There has to be a better way. Because, again, we virtualized to make our lives easier, but did we build a better mousetrap, or did we add more complexity, more cost, more vendors, more support contracts? Everything we didn't need in our lives, we just added those in as smaller components rather than one big one. Isn't there a better mousetrap already? Yes. This is what Hyperconvergence is doing for the infrastructure. Or doesn't get to what the actual definition is. So no matter what any vendor might tell you, we feel we can give the canonical definition of hyperconvergence since we're the ones who coined the term. And it wasn't a hyperbolic statement of being this is mega converged or super converged. It really means hypervisor converged storage. So it's the integration of storage, compute, and virtualization layers all in one infrastructure stack, so into a single solution. The only real other truly hyperconverged player platform that's out there is Dell/VMware, depending on what you want to call them these days, and the Evo Rail or whatever has also been rebranded. That's a truly hyperconverged platform. VMware being the fact that they own that software stack and they're providing it as a single solution, that's truly hyperconverged. Everything else is really just taking the management of that storage and shoving it inside a VM that you have to give a significant amount of resources to. If you look at our I/O path, we wanted to find a way to simplify that. And we were able to do that by cutting out all the storage management and forgetting about saying, how do we manage that storage? Let's build this giant VM that just runs inside of all of my physical hosts that manages that storage for me. Now that seems like it's again, we're shifting the way we're spending our time. But if you just take a VM and say, I want that VM, when it's writing to its disk, to go directly to the disks that are in the cluster, I can simplify that path from 4 steps, or from 7 steps to 3. So it's less than half as many hops to get that data down to your disk. So what is hyperconvergent? What is it not? Again, it's not hyperbolic. We aren't trying to say this is a new way of doing converged infrastructure. It's hypervisor converged infrastructure. And it's not another appliance. This is not a VSA or virtualized storage appliance that manages your storage for you. It's not a separate stack that just the vendors are delivering as they're forklifting a whole rack in there and they've got all that configured for you. Yes, it's easier, but that's not hyperconverged. That's just a vendor delivered stack for reference architecture. And beyond the definition we talked about, it's really about providing, and I like the statement Scott Lowe has about cloud-like economics without compromising performance, reliability, or availability. And also scalability and affordability, right? That's the whole idea about cloud. But we don't always want to shift all of our data to the cloud. We're not comfortable doing that yet. Not many people are. But if you could have that same experience, a cloud-like experience on-premise, without having to worry about the risk of your data living somewhere else, that's another benefit of hyperconvergence. And specifically with Scale and HC3, we've taken away the need to have to worry about any type of other hypervisor. There's no VMware licensing cost for that. You don't have to worry about specific management servers. You know, if you're still using a vSphere model, you don't have to install a back client. They're slowly moving to a web-based interface. So they're drafting a little bit behind us in that. There's no storage protocols to understand. You don't have to have specific admins just to manage your virtual environment. And you don't have to go and spend thousands of dollars every few years when they completely reboot the entire software stack. You have to understand how to manage it. You don't have to go back to training and understand how to work this new version that's changed so radically from the way I knew it before. And the other downside of that is when they make those changes that are so sweeping and so broad, a lot of times people are compelled to not adopt those new versions and they don't want to take the downtime, right? It's hard to shut down your whole environment if you're upgrading just a single component. You know, you really have to have a PhD to be able to understand just what you want to buy the next time, the way they make licensing so difficult. So going back to hyperconvergence, why can't we make it simpler? Added a greater degree of high availability and scalability and make it easier. The affordability is just going to come as a byproduct of the fact that we've simplified the stack. You're making it, adding greater HA and scalability. The scalability part is also interesting because today, most of the times if you want to add in additional resources, you have to look at what you've got and make sure that there's going to be compatibility with the existing infrastructure you have. So are you going to break compatibility if I'm adding in this newer vendor or this newer firmware version running on that particular SAN? Does that affect how I'm supported with ESX? And if I want to add resources in a Hyperconverged platform, the idea is that you just go and add those in. And it's supposed to be non-disruptive and easy. It's not always non-disruptive and easy in the traditional model. And if you can make it simpler by taking away all of those management interfaces, your SAN management interface, your vSphere client, whatever orchestration layer that you have for your virtual environment, along with your physical hosts, you've got any type of lights out management, and then beyond that, you've got your network layer. And each one of those components and discrete stacks has their own support contracts and life cycles and firmware versions and update requirements. And it's a real headache to try and mesh all those together. So as far as hyperconvergence and what we've done is we wanted to take those ideas and those core values and say, okay, we can deliver this as a stack. And we can do it better than we've been doing it before. We can do it without the complicated I/O path that we've seen. We can do it without having to worry about scalability or the ability to add resources on demand. So we're adding performance as well as simplicity and keeping it in a more affordable manner. And also built into our product are some of the other key components you need in your infrastructure, specifically the ability to do some type of DR, whether you want to have it as a hosted service where you can replicate your VMs to our private cloud, or if you wanted to stand up a second cluster at your own remote site, the ability to replicate your VMs live and running without having to install any software inside of them is also built in. And now we also have a tiered offering, so as a true storage tier, the nodes that we have with SSDs built in, it's not a cache for all of your I/O. It becomes a true storage tier. So every write will always go through those SSDs, but you have the ability to granularly control on a per VM and per VM disk level how much flash you want to have it allocated, whether 100% all the way down to 0. There's a slider between 0 and 11. One of the founders and the UI architects is a very big 80s rock fan. I forgot who was to turn it to 11 on the amp band, but I can't think who it was. Anyway, that's why it's 211 instead of 10. But you don't have to have another, all flash array or another way of managing just your flash environment. Why not just let the underlying technology, because again, with us owning that storage stack as well, we have complete access and visibility to the current IOPS, the read-write patterns of those underlying VM disks, because it's not a file somewhere. There's not a whole lot of information you can get out of a file that's representing a disk. But when you're presenting that disk to the operating system as a block device, that gets written directly to any hard drive and cluster, we have control over that. So we can see where those hot blocks are and whether or not they need to go dropped off to SSD or they can stay on spinning disk. And if you wanted to let us automatically make those decisions for you, you can do that. And we're constantly evaluating the hot blocks on the disks. Or if you wanted to just say, okay, I want this to have all flash or 90% flash. Having a management interface that's web-based and that is not going to require some type of database or backend for it. We wanted to have that. Direct access to all the storage in any given cluster. Having a hybrid model. And also talking about the updates before. Rolling updates. I was talking about this yesterday with someone. I've really grown to take it for granted to not have to worry about taking downtime anymore for updates. When we have a firmware update that's released, all we will do is just on a node-by-node basis, we'll live migrate the VMs off of that node. We can perform any updates we have to. If we have to reboot it, we can do that. We can shove that node right back into the cluster and move the VMs back on. Because we're not reassembling a file system underneath or having to go and rebuild a already file set. If there's a disk failure, for example, that takes a few seconds to get that node back on and to the point where we can start moving those disks or those VMs back. Do the same thing with the second node, third node, etc. And you can get a cluster up and running within an hour, And I've done it within 30 minutes. I was on a webcast, and it was the challenge to get it done in under an hour, and I got it done in 27 minutes. Because really, again, you're not configuring your physical hosts, then configuring servers or storage, then configuring your hypervisor, then getting it access to storage, setting up your vSphere, your orchestration, etc. What could be easily a 40 to 60 hour engagement is really done in less than an hour. There's 2 IP addresses that get configured on each node. And a cluster consists of at least 3 1U nodes. It initializes, and you're ready to log into the web UI and start uploading ISOs through a drag and drop interface. The real test is, okay, that's great, but one of the things I always hated as an IT decision maker was I wanted to know a lot about your product and your company, but I didn't want to have to fill out a form and figure out how much does this really cost. Just give me MSRP, so we're willing to share, what are the upfront costs to see. So these cluster costs are inclusive of the first year of support as well as the installation services. And the installation services, again, they're delivered remotely. It's all, you walk through the install process over the phone, but it's really so easy. After about an hour, we walk through some basic housekeeping tasks in the UI, and you're off and running. And again, if there's assistance that's needed with moving workloads, if you wanted some help with us to do that, we can provide some assistance and guidance with that. But to get started, these are entry-level costs, and that one on the right is inclusive of a tiered model with SSD in it and 10 gig networking. So oftentimes, we've encountered people who are at an ESX licensing precipice where they're about to renew their support with VMware, and just the differential in what they would have spent to renew their VMware licensing paid for almost the entire cluster, or even at the very least the second one at DR. And the other thing about the models is that you can mix and match. You're not forced to say, okay, I bought an HC 4000 failing, I need to keep adding those on. I can drop the 2150 or 2000 on that. I can mix and match all day. Now, obviously, you'll want to be cognizant of mixing and matching 10 gig nodes and 1 gig nodes. You're going to have your least common denominator speed there being 1 gig, but it's certainly allowed and tested, and you're more than welcome to do that. Mostly because one of the other big FUD that gets pushed out of a hyperconvergence is that you wind up with vendor lock-in. And I guess to an extent, you could look at us and say it's a whole stack, and aren't you providing vendor lock-in? Well, at the end of the day, we have the ability to export a VM right out of the user interface, and it's going to get you that traditional backend file format, XML file. You can ingest that into any other hypervisor you want. We can also do that in the reverse process. We can import BMDKs, VHDXs, QCOP2s, RAW, any other file format. We can ingest those and turn those into a scribe-backed stored VM. So in this whole stack of vendors here, and it's when it's like, here's the top 10 best vendors. Well, I kind of feel like that's most vendors that I've really heard of and seen on a daily basis, but this is focused on who's got a better understanding of a mid-market grasp of technology. And we're on that list, and we were the only pure hyperconverged vendor that's privately held. And Dell is too, and I guess we're lumping that in by virtue of the Dell EMC acquisition if that ever goes through, but we are the only real pure hyperconverged vendor that's privately held, which gives us a lot more autonomy in being able to manage our product life cycle and our product roadmap. So again, talking about a VSA being, this is a VM running on the hypervisor, and it's managing all the storage for you. So the Nutanix, the SimpliVity, the SpringPath, those have VSAs. On each one of their physical hosts is a controller VM, a VSA that's running. And they take anywhere between 24 to 60 gigs of memory a piece. So you're consuming a significant amount of your available resources to run those controller VMs. And you have to have one, if not multiple, on each one of the nodes, just to provide fault tolerance. So getting back out of that same path, it's just like it was before with the traditional I/O path, only every VM then has to go and communicate through these VSAs. So every I/O hits that VSA. Then it has to go and replicate that twice to a second VSA on another node in another part of the cluster. That I/O path is extremely complicated, and it works, but you have to have extremely fast underlying storage. You have to have basically InfiniBand networking at a realistic speed to be able to take advantage of the fact that this works, it's made my life easier, but if I don't have fast enough underlying storage, it's really not going to do anything but add another step. You've made it a little bit easier on yourself, but the performance impact can be significant. You really have to have enterprise level storage to be able to get the same level of speed that you would get with either physically direct attached disk or with our direct connect path. So again, VSAs, you've got to throw a whole bunch of resources at them to get them to be up and running and to manage your storage. And it's consuming memory and resources that you could run additional VMs on. I'm sure you could probably add additional resources and they would love that. But why consume so many resources when you don't have to? And it's hard the VSA approach also makes it hard to scale up and scale down, but it also makes it hard to scale down to a non-enterprise packaging without basically neutering the product to make it realistic features that you want to use, right? That's what the enterprise companies do with SMB or mid-market. Here's a great product with all these amazing features, but for us to make it affordable, we're just going to take away all the features that make it valuable, and here's this leftover poor piece of software that it's not done a whole lot for you because you have to go and add on Beam or add on another DR product, do replication or snapshots. So hypervisor embedded storage, which is really what we feel is the future of computing anyway, is really what allows us to put that whole SMB data center stack in as little as 3 nodes, to be able to get it up and running less than an hour where you're creating VMs, and also provide built-in features and functionality like snapshots, like things like built-in replication DR. These are all things that are just a part of the product. They're not licensed with extra features. There's never different tiers of support you buy. You just buy the product, and you have an annual renewable support cost of 12 to 14%, and the support's all handled by us. We aren't going to deflect you to the hardware vendor because we also know that because we own the whole stack, we're responsible for supporting the whole stack. We don't want to send you to a vendor and put you in the middle of a circular figure pointing game when VMware is saying it's your storage is saying it's VMware, and then maybe your storage is saying, oh, it's your physical host. Maybe VMware is saying, no, it wasn't that, it was your network. You wind up spending hours pulling your hair out to get to a root cause. We have that whole stack, and we support it. We're pretty proud of the way we've done that. Our Net Promoter Score is currently 85, and that's basically done on a scale of -100 to +100. And if you ever gotten surveys after a call and you fill them out, a lot of times it's ranked on a scale of 10. So the way the Net Promoter Score is calculated is a 9 or a 10, you get a 1, a 7 or an 8, you get 0. Anything less than that, you get -1. So your score range, on one question, you go between -1 to +1. But obviously, to get a higher score, you have to be getting a lot of 9s and 10s just to get a positive score. Ours was 85. Costco and Amazon, which are typically industry leaders in Net Promoter Score, I think theirs were around 60 for the end of Q1. VMware is 28, and the cutoff for world class is 40. But with us being at 85, that's feedback we get directly from our customers, and it's also representative not just of their support experience, but would they recommend the product based on their support experience. So it's a testament, I think, to not just the loyalty to us, but the fact that this is Hyperconvergence, and this really has made my life easier. And if you look at our customers, we have larger names that may not necessarily associate, or you may not necessarily associate with SMB or mid-market. But a lot of these companies, like Hilton, for example, that's a franchise organization, so there's a group of Hilton hotels in Toronto that are run by a handful of IT guys, and they were able to consolidate 3 racks into about 10 U. But that's a distributed enterprise, and that's really what these larger companies are. These companies here that you see, you probably never heard of, because these are really what our true market is. These are local businesses, less than 500 to 1,000 people, or less than 10 or less IT people. That's really where we're going after. We aren't going to go after enterprise customers or products or consumers, because really they have different needs, and they have the funding, they've got the expertise, they have the resources to be able to have a staff of 20 people. 5 of which may just be storage, 5 of which may just be servers, etc. And at the end of the day, hyperconvergence is about this. It's about what's your TCO? How can you reduce that? And TCO being quantitative and also inclusive of your personnel time that you spend managing your infrastructure and your environment. What's that all costs add up to you? And so Saffron Power is a part of Goodrich Aerospace in the UK, and he just sat down and said, these are the things that helped me immediately have an impact. And if you look at those numbers, it's eye-opening. And the Leonard now works for us. He was so excited about his experience. We've had 2 people who were very adamant supporters have now joined us as employees. So thanks for a great way to hire. Back to the support and what's really included. Again, you're getting installation. We don't do on-site installation. We can, and we have in if it's needed. But it's so simple to get up and running. You're going to spend more time breaking the boxes down, throwing away the styrofoam, and getting them racked up than you will actually configuring nodes. So again, we help you walk through that process. You'll get a full environment for them. But there's a lot of different ways for us to help out as well. Again, if you wanted to have set up your workload migrations, whether they're physical or virtual, doesn't matter which hypervisor you're coming from, we can help you get those moved over. If you wanted to have us help you set up replication, that's something we can do as well. And that's also not hard. Standing up a second cluster, if you've got a second site, you're just going to configure it and get away you go. So what do you have built in for DR? Obviously, we're talking about built-in cluster replication. That replication technology leverages our snapshots, which are extremely thin, and you can take thousands of snapshots if you want to. Keeping that huge queue of snapshots has absolutely no impact on your I/O performance. We also have a hosted DR service. So if you didn't have the funds or even a second site, but you wanted to take a few, handful of mission-critical VMs to protect for starting at $100 a month, you could replicate those through a secure tunnel back to one of our data centers. And again, this is some information about that. That also includes the DR test twice a year, and we built out a pretty comprehensive run book. So it's a DR plan that, again, at the end of it, we mail you a bound copy of it, so you can say, look, I have the DR plan. Oh, and by the way, I just tested it last month, and I know it works. So whether it's an audit checkbox or it's going to help your business insurance go down, it's nice to say, okay, I've got a DR plan that I can test. And again, whether we've helped you set it up or you just went and got a second cluster and deployed it yourself, it's so easy to do DR tests. I'll actually show that a little bit. Talk a little bit about our heat map technology. This is our tiered storage. You control the priority. This can be done on a running VM. You do not have to shut down the VM to make changes to the tiering. If you just, again, did nothing, we're going to automatically look at the heat map of that disk and do what needs to be done as far as moving those disks and those writes across the tiers. But all writes, regardless of how you tiered that disk, unless you set it to 0, all writes are going to go through the SSDs. So that's going to minimize the write latency. Rolling updates. Yeah, this is something it's so nice to be able to take for granted, to not have to worry about, I have to shut everything down and I don't know what's going to happen when I upgrade just one component but not the other. You just click go, come back in an hour, and all the while your VMs are up and running. The only thing you lose access to is the UI. You can still log into your VMs, you can still RDP to them. We'll just have that little block running. Our VM snapshots are pretty cool, and this is a byproduct of our technology for storage. Where there isn't a file, there's not a VMDK that actually represents that disk. It's just an object, so we keep track of where those disks are distributed on the cluster. We track where those blocks are, and we know that if I take a snapshot at this point in time, here was that VM look like. I can have an exact point in time. I can take one 5 minutes later, and we can also track, okay, here's the blocks that changed, and that's the only thing we'll have to keep. If I wanted to clone 100 copies of a specific VM, or clone 100 copies from a snapshot the night before, maybe I'm using a gold image and patch Tuesday went awry, so I want to go back to my previous night snapshot. I can clone that VM 100 times, And those 100 VMs are gonna all share the same pool blocks. As you power them on, you've got all the other standard churn that goes on inside of the box, you know, paging, virtual memory. Obviously that size will grow, but if you have a core install with 10 gig VM and you clone it 100 times, you're gonna be using 10 gigs. So those first blocks are all shared. And if you deleted that parent VM, doesn't matter. We'll go ahead and propagate those off to the next VM in the hierarchy. You can get rid of those. You can manage all your snapshots. You can clone 1,000 times if you want. It's not going to have any impact on your I/O. There's not going to be a time where they're having to go back and the file system is everything safe. It's just immediate. And you can schedule it if you wanted to build up a 30 deep list of, I want to take one daily, keep 5, one every 5 minutes, keep 20, one every 15 minutes, keep 10, etc. You can set up a very complex recurrence rule to say locally, if I didn't have a second cluster, I want to have copies of these VMs. I want to have these snaps, at least to have it daily or maybe once an hour to roll back to it. For replication, that same snapshot schedule will always get propagated across the other VMs as well. So if I'm taking 20 snapshots a day for this VM, maybe it's 15 every hour and 5 daily on your remote cluster, those can be represented the exact same way. So you always have the identical and congruent recovery points. Okay, cloning this takes just literally a few seconds. So if you're using templates, it's nice to have one sysprepped OS because all the common block just stored once. And you're not having to worry about, okay, is this the root VM? Is this the parent? You know, if I delete this, is anything going to happen? There's absolutely no worry. We don't expect you to keep track of that. In our export, we can drop those full VMs off to a SIF share somewhere. It doesn't matter. And again, you get the VM back into a format that if you wanted to do something else with it, you're more than welcome to. And you can also get, export from a snapshot. Get a VM if I wanted to say, okay, here's a good copy, just in case I want to have a copy of that somewhere. I can drop that off to a share. It's better for archival. It's not really a DR option because it's going to take a little bit longer because in that case, you're not moving a snapshot off because it's the full copy of the disk. If that's a 100 gig allocated disk with maybe 10 gig installed, it's going to be a 10 gig copy off. But again, you have that full disk to be ingested in other hypervisors. This is just a visualization of our DR. You can replicate on disk-like clusters. So if I wanted to have a lower end cluster at my DR site that's maybe just SATA and it doesn't have the same stack of resources, maybe doesn't get, not even tiered. It doesn't matter because if you're saying, this is just DR, I realize these are mission critical and they may be a little bit slower because they're running on some nearline SAS disk instead of SSD and SAS. Okay, that's fine. There's no requirement that you have parity between what your point you're replicating to. So it opens up the ability to say, okay, I can have an inexpensive DR site that also you can use for tested or however you want to use those VMs. And when I'm ready to replicate, I'll get to the live demo here. I can just go back, replicate a VM. Just like I'm cloning from a snapshot locally, I can pick a point in time. It's going to take a few seconds to clone and power that on, and away we go. Alright, I'm not going to talk about this anymore because I'll just forget about the PowerPoint demo and I'll get a lot of live cluster replay. Has anyone else been having problems with the Wi-Fi being marginally slow? I was just going to say marginally. Yeah, if you see FBI surveillance man, that's the name of my phone, so it's fine. I thought I was really clever when I was doing that. I was at a customer who was, basically they do, Department of Homeland Security, they do their IT, and they don't allow anything in as far as network. Like phones aren't allowed to be turned on, and I couldn't get on the internet, obviously, and I was trying to show them how to do replication, and I said, okay, I'll just tether, and within probably 5 minutes, these guys were running to the FBI, and Who's got the FBI Supreme saying? Well, that's me. Do you think you're clever? I thought it was kind of funny. That's just me. Okay, so any browser that's HTML5 compatible, which is pretty much any browser today. So when you log on to a cluster, regardless of which IP I go to, I'm going to get the same view because it is a cluster. And I'm going to get a visual representation of these are the nodes. So in this case, this would be 4 1U nodes. I can see each node, 2 of them at 126 or 128, the others at 256. We do reserve some for obviously the OS partition. And I can see, these are the ends of how much RAM they're consuming. If I wanted to just get console access, I can double click on it there. So again, this is all going to be web-based. You don't have to have a client to install and get these up and running. So he talks about, okay, it takes about a half hour, let's say, to get to this point of setting up a 3-node cluster. Once I've done some basic housekeeping tasks here for what's my name, where do my alerts get set, what's my DNS, etc. At that point, I can either upload or just drag and drop ISO files right in the browser. And I'm ready to create a VM. That's the extent of it. No storage configuration. I'm not specifying which VMFS area or partitions is going to live in. I'm not specifying what type of storage is going to be back to because I know what's on my cluster. I'm not specifying is this going to be a fault-tolerant VM, is it part of SRM, going to replicate it. I'm going to just create a VM because this is, at the end of the day, your VMs, that's the atomic unit of what we're supposed to be keeping track of and measuring, and not all of the underlying resources. And we never get to spend time just keeping track of our VMs because we're managing the underlying resources. And that's really the goal, is to get to something that is a one-click to create a VM. So I've got that VM created. Now I want to, let's say I haven't installed anything on it and I just want to set this up for replication. I don't have to do a whole lot else except say set up replication. In this case, I've already got a remote cluster set up. But I would just pick that target cluster, say replicate. It'll take a snapshot, ship that snapshot across the wire, and then as it's replicating, all the change blocks that it's sending across are going to be managed. So here's a live replication VM that's running. You can see it's using just the default replication schedule, which is to say take a snapshot every 5 minutes, send what's changed, and keep rolling. And it'll keep 5. And 5 minutes is that's our goal and default replication interval. If you've got enough bandwidth and your change rate is sufficient enough, 5 minutes is certainly easy enough because a basic Windows VM and Windows VM churn is going to do about 40 to 50 megs. And you can see here that baseline snapshot that was taken. That's really the full size of that VM. Even though it's got a 100 gig disk allocated, it's really only using about 6 gigs. And then these two deltas here, that's just changing what's happened in the last 5 minutes. But if I wanted to say, okay, and you go back to 9:30, because at 9:40 I installed patch that went awry. So okay, there's that time snapshot that I want. Let's go ahead and give me a full copy of that VM so I can power it on. There it is. So I had set this VM up to replicate back to one of my clusters. And given that there's nothing on it, it's probably there. But I do have a few others that are being replicated. So. Got a fair amount of warning, so ignore that. Yeah, this one will pop up, and we want this always to be front and center. Insufficient free memory to start all VMs and alternate nodes. Basically, that warning is important for two reasons. If that condition is set, you can't do a rolling update. Means there's not enough free memory to power off and reboot one node and to move those VMs elsewhere. It also means if there is a disruption and a node died or got powered off or someone tripped on a cable, we'd be in the same situation where that node, any given node went down, we don't have enough free memory to start all the VMs in the remaining node. So we'll start as many as we can, and it's based on the size of that VM, so we'll start with the biggest ones and get those running, but you can get that down below the 72% threshold for 3 nodes. In this case, yeah, so I've got a 3-node cluster. So this is how it's going to be visually represented to me. On the back end, I can see here's my capacity with this space I've used. I wanted to see, okay, how are those writes actually distributed? The goal to make sure we have consistency in the data is that all of the writes are distributed about as evenly as possible on every disk in the node. So this is a 3-node cluster. We've got 4 disks per node. That last one is an SMB. I've got a little bit more written out the back because I was playing around and setting some VMs to 11 for performance testing. But yeah, we really try to make it as evenly distributed as possible. So when it just dies, all we have to do is take what's on there, dump out that, let's say, 300 gigs, striped across the remaining disks. And all the while that stripe out's going on, unlike a RAID rebuild or a file system recovery, there's no I/O impact. Because we know that there's another copy of that VM data. We know that there's a copy of everything that was on that disk elsewhere. So it takes just a few minutes to get that striped out across on a 10 gig cluster, a little bit longer than 1 gig. But all the while, you can just take that disk, put it back in. Don't have to worry about, do I have to reassemble a file system, put this back in, a RAID set. You just put it back in. We know that there's a new disk there, and we'll start redistributing the writes back to it. Okay, so I've got that first snapshot that was done, of course, at 0 bytes. Grab a snapshot, we're going back to the first cluster we're at. And it'll show up like a replicated VM card as a looks a little bit different, just so that you know it's a replicated VM. Really, the only thing you can do is clone from the snapshot, because it's just a target that's containing the data. In this case, this particular type of cluster, as I was talking about, there's not parity in the memory necessarily, but even though this is pretty close to being full, we try to keep all of our data distributed as even as possible. Because here's what's happening in a disk failure, or if there is a multiple failures at the same time, with the traditional model, regardless of virtualization or anything else, you have to put that file system back together and make sure that everything is intact, right? If you don't have a file system and we've lost 3 or 4 disks that may have contained the only 2 copies of those, a specific block of VM was referencing, we can get those disks back in there, and those blocks may be missing. But it's not like the entire file system is destroyed, so your VMDKs are gone, and everything that's relevant to your VM is gone. Operating systems do a pretty good job of being able to recover themselves. So if we can get, here's your VM, there's going to be a few holes in it. Let's use an FSCK or a check disk and let the operating system recover itself. That's the other beauty of that, is that if there is, if there was any type of disruption with multiple failures, the OS can assemble itself. Never had that happen. We've had 5, 6 disks out at the same time. It's really, when you take away that file system idea, it makes it significantly easier. Again, this is a visualization of the stack that we have. So, and this is how we feel hypervisor converged storage or hyperconvergence should be represented. Hypervisor, storage, and direct access to it. In each 3-node example, we have a backplane network that's private, it's non-routable, should either be a dedicated VLAN or a physically distinct switch. The virtual disks inside of the VMs, and from there, the VMs are writing directly to those, and the scribe underlying layer, which is our, that's our technology. It really is understanding that the data placement and the allocation has to be optimized, and it will handle all those writes and reads in the backends. So the VM churning reads and writes, churning writes out to the disk, the scribe is going to put it the best possible places that you can. And again, taking into account the hot blocks on that disk is going to need to go to SSD, as well as the IOPS and latency on this disk. Do we need to maybe start pushing some of those writes over to these other disks on these other nodes because they're freer or they seem to have a lower load? We have control over where those goes. So what happens if you have a disk failure? Okay, so this disk is wiped out. Those 2 copies, we knew that they were somewhere else. We'll just reconstruct them from an existing copy and move them to the remaining disks. Now we're back to full tolerance, full fault tolerance. We can put another disk back in there, and we'll start populating that, whether it's with new writes or getting the other ones back on. But at the end of the day, there will always be 2 copies of the data. And with the writes going to flash first, if you've got a tier cluster, that makes those 2 initial copies much faster. And that same model happens if you lose a node. You have to be able to withstand that as well. So when that node gets knocked offline for whatever reason, it had running VMs, and we'll just move those VMs to any one of the remaining nodes. The tiering that we were talking about, so in the background, it's constantly looking at what's the heat map, what are the hot blocks. If you set that slider to 11, it's going to go on all flash, and we're saying, okay, you want to do that for a purpose. If you set it at 0, it's going to have absolutely 0 flash. And 4, which is the default, basically saying, we'll let you make the decisions. But again, so it'll say every write's going to go to SSD, and as we evaluate it, does it need to stay there? How hot is that? Let's start getting those dropped off to spinning disk as we see SSD. As cool as animations are. I can only get so much fun out of PowerPoint. So I kind of like to open it up for questions if you guys have any about hyperconvergence or us or technology. Have a nerdy roundtable.
So you had 3 nodes. Can they be wide area networks?
Can they be?
I'm sorry, across the wide area network. How far?
Oh, okay. They have to be under the same roof, really. Distributed clusters are, that's a Q2 2017 feature. We've had a lot of requests for it, not just on a WAN, but on like campus networks. People have on a college, so they have node 1, node 2, node 3, node 4. They want to be able to distribute like that. But today, just because the backplane is really sensitive to latency, they have to be under the same roof.
And the sales slide that you had with the pricing, can you talk more about the capacity?
Sure.
It was a little hard to see from here for me. I know, man. I'm just a whiner.
When you advertise like 18 16 terabytes, whatever, is that usable storage or is that
Raw.
before Magic covers that?
These are all raw storage, so divided in half.
And you did say that you can mix 1,000 with 2,100.
Yeah, you can mix and match nodes, just if you're mixing and matching nodes, there's never going to be, with different disk types, so this has 7,200 RPMs data, that's got SSD and SAS. There's never going to be a guarantee that all those are going to be on SAS, but yeah, you can absolutely mix and match. There's not versions of the software firmware that are just for specific nodes. There is one version that is applied to every single platform. So yeah, all these capacities are raw, so this is kind of this is where our three starter nodes look like, and we go up to 8 even. And it's really going to depend on what are your needs for memory and disk. So for a starter 25.5, you get 6 terabytes raw capacity, or usable capacity 12 raw, 96 gigs of memory. That's a 1 gig interface. But I mean, for a decent number of workloads, basic file and print server AE stuff, like that's perfectly fine. And that also makes a really great DR target. Those are a little bit short on memory. They're capped at 32 gigs per node. And these are actually going to be replaced shortly with a newer platform that has more memory options. And memory is probably the most finite resource for us. We don't do any diluting. So when you create a VM and allocate 8 gigs to it, until it gets turned on, it's not using any, but once it's turned on, it's consuming a full 8 gigs. So it's not like that's being shared. KVM is capable as a hypervisor of doing that. It's just, there's a lot of risk and computation in having to maintain memory states like that. So as inexpensive as memory is, we figured why bother with that risk of corruption and just allocate memory. Outside of the 1000 family, every one of the others can be upgraded in memory. So if you're starting with a 2150 that starts out with 128 per node, that can be doubled to 256 per node. So the max cluster size today is 8 nodes, but as dense of resources as you can get. I mean, if you do this 8 node 4150 and completely max it out, you've got 4 terabytes of memory. Raw capacity, so you got 6.4 terabytes usable SSD and 48 terabytes usable SAS. So that's a fairly sizable chunk of resources. And it's not that we don't, we can't support or the technology doesn't support large clusters. Is that as you start going above 8, n plus 8 clusters or nodes in a cluster, the risk of multiple failures becoming a problem starts to get, that's not linear. It's exponential growth there. So, especially with these, because the 4000 series have 8 disks per node instead of 4. So the 2000s, these all have 4 per node, and from a tiering standpoint, it's 3 spinners and 1 SSD. 4000s and 4150s are 6 spinners and 2 SSD. And those are using enterprise grade we're using, but those SSDs basically have double the capacity for each, so there's never going to be a trim or a slowdown as that thing gets aged out.
So in a scenario, data was living in 2 different nodes.
Yes.
How does it scale when you have 8? Does it still present in 2, or is it spread out across all of it?
It's still 2 copies. There's the ability to have 3 or 4. I mean, we can have multiple copies. Obviously, that's going to change the I/O performance. But the placement specification, that algorithm that determines where those go, it's just going to distribute it again across. In this case, I've got 12 disks that I can spread it out. In that case, I would have 64 disks to spread it out across. So it determines optimally where those go. Really, the 2 goals of that placement specification are fault tolerance, so a single disk doesn't bring down, and performance, so where do those blocks really need to go. And then the third goal, that just winds up naturally occurring organically, is to have even distribution. So even though it may seem almost like a round robin, we want to try and keep those disks aligned so that there's never one that's almost full and you got one that's half empty. That's why when you add a node to a cluster, even though it's non-disruptive, you can just shove it in while the cluster's running and give it an IP address. Afterwards, we'll run a rebalance just to get the data distributed quicker. You would never have to, it's not required, but we just recommend it.
So it's a single pane of glass for all the members in the cluster?
Yep, so if I go back to this cluster, this one's got 4 nodes. If I go to the last, the third, I'll give that node 4. I'm going to log in and I'm going to get the exact same view as I had. So it really is a cluster that you're managing all the time. Yeah. And so there's no client to install. You know, these, with the, I think this is going to change in the next UI release. These are just individual VMs that are running, and you can hover over and see it and double click to get access to the console. When you start getting denser, more and more dense memory in the nodes, it's getting harder and harder to see what the names are. But,
yeah.
That's some change there. And you know, I can say pick here if I wanted to, live migrate to it and all that within here. When everyone asks about live migrate, it's a cool feature, but there's never going to be a real reason for you to want to live migrate, except for a few exceptions to that. If you had a cluster like this, and let's say you had a VM that took 120 gigs of memory for some reason, you would want to make sure it's always going to be running on one of those. And even in a rolling update scenario, as long as you had enough free memory, we would know that, okay, this is a huge VM, it's going to have to stay on one of those two. We can't migrate it over here. So that's a case where, when you move VMs around, we're going to say, okay, you moved it there for a reason, and unless that VM or that node gets disconnected, disrupted, or we're doing a rolling update, we're never going to move it off. Because in addition to having memory upgrades, you can add processor upgrades as well. So when you're at a point where you need to add resources, the individual nodes themselves have the ability to upgrade their components. But also, if you say, I just need to add storage, you can add in a storage only node. So you'll get additional storage capacity, additional writes, additional spindles for speed. It just won't be an option to run VMs on it. But that's, at the end of the day, most of the time, when our users are at a threshold of adding resources, they're really just going to go ahead and get a whole other node, because that's going to give them more compute, more memory, more storage, obviously, and adding it in is non-disruptive.
So it's not just attaching like a shelf of disks, it's actually...
Yep. You would take out, it's a full, if you're doing a storage only or a new node, it's just a full one-use server. There's no disk options. Just add in a shelf. And in the guest, often you can connect to any external storage you want. We have customers that have a huge all-flash array that they use for storing medical imaging, and they have their connected to the IS because there's no limits there. And they actually may get rid of that if we, once they start getting their tiering implemented. So. Yeah, in the live migration process, you can see this will take a little bit longer because we're basically synchronizing the memory across the backplane. In that case, 24 to 48 gigs will take a while to make sure it gets in sync. But all the while that's happening, the VM and the I/O inside of it has no impact.
What are the solutions you want to use for backing up or say it's all virtual, the person comes to mind and feed or something?
Sure.
With all your snapshots, I'm assuming you still would do the backups, have some other software for backups or something like that?
We recommend that you have something for filing. Obviously, this is VM level protection, and you can easily clone a VM, power it on, and extract a file out of it. You'll want to make sure you disconnect the NIC or give it a different IP or names. There's no conflicts. Later on this year, next year, hopefully later on this year, we'll have read-only snapshot capability where you can just pick a snapshot and basically mount it and pull that file out. So if I need to get access to something from 9:31, 5 minutes ago, or 5-minute interval, I can go back to that snapshot, mount it, and pull the files out. We have a tool that you can use as well. That'll basically, it allows you to clone a snapshot, and it's an ISO you put in, and you can put it in the small Windows PE environment, and you can pull the files out that way. But read-only snapshots are coming. That's still, we wanted to try, and we really don't want to get something that's going to be required to touch the guest at all. Our goal is to not be involved in installing software, installing shims. I mean, we do have a set of drivers that are really not ours. They're Red Hat's drivers, kind of like VMware tools, so they're virtualized drivers. But that's something that's installed when the OS is created, or you change it out of the fact. Other than that, there's no guest tools that get installed. Once that read-only snapshot option is out there, though, there is a small serial device driver that you install for guests, but again, no software. But as far as what's in use today, I mean, most people have a backup product that they like for file level, and there's no reason they couldn't keep using that. I mean, we're not any different from any other. At the end of the day, you're running an x86 workload with just like you were before, and it's backing up to a tape array or anything else you want to. But there's also the likelihood that if someone's at an infrastructure refresh cycle, they're probably buying or at least evaluating other products that are out there. So we see the whole spectrum of what's in use. I would say the majority of what we see is probably Barracuda and Symantec. That's all anecdotal evidence for me, so there's nothing supporting that, but that's what's out there, yeah. And the scheduling is pretty slick too for snapshots. If I want to add specific recurrences, so I want to take once a day at 2 a.m. I'll take a snapshot, and I'm going to keep 5 days. And every 15 minutes, I'm going to take one and keep 3. And every 4 hours, keep 4 of those. Save this, and I'm going to apply it to a VM that I'm replicating. So we were just using the replication default schedule. I can now pick that one I just created. So now, if I didn't do anything, it's just going to start taking snapshots in the interval I use. If I set up replication, pick that target cluster, it's going to use that same schedule. So every 15 minutes, every hour, once a day, those log it, mirror and replicate over there. But this is, this is the goal of what hyperconvergence is. And this is when we set out to build a better mousetrap by building a simpler one. That's really what not just we wanted to do, but what the industry is starting to gravitate towards that trend. We want cloud-like simplicity. I love the idea of Amazon and Azure being able to create and provision a VM without having to care and understand what they're doing in their data center and what's providing those resources. I just want to create it because that's all I care about. And that's the goal. Abstract everything that's underneath at the network layer, at the storage layer, at the compute layer. I don't want to have to care about how those are set up, how they operate, what protocols they're using. I just want to know that I can use those and that those resources are going to be available when I need them, and that those resources are fault tolerant. And that when I need to grow and scale up, that I can do that without having to rip and replace everything, without having to call every vendor that I have access to and that I have a support contract with to get everything reconciled and say, okay, I've spent 2 weeks now figuring out what I need to buy, and now I figure out is it possible. Oh, I ran through both. Okay. Well, I'm I'm a little bit past my time, so thanks for coming. And if you guys have any questions, we're at booth 31.
Awesome,
Stop
see you
by.
there.
Thanks a lot.